All right, for today's lesson, we are going over something called the unit circle, um, and specifically the sine and cosine functions that show up within the unit circle. This is a very hands-on day, so hopefully you are not self-pacing. Hopefully, if you're watching this video, you're trying to make this up. But one important thing that we're going to need is you're going to want to have this link pulled up. Also going to access it doing this QR code, which gives us a hands-on view of what's happening with the unit circle. All right. And if I go to that link, which you should, the only thing we're going to play around with here is this blue slider here. And as I do that, notice how in this circle, I get a black line that moves and rotates around. Watch that black line. And in that black line, notice how we can always create some sort of triangle wherever we're at, right? The black line is the radius of our triangle. And then we have some triangle height. And then we have some triangle width. And notice if I move this again, okay, now I move it over here, and now we get some other triangle. Okay, the hypotenuse, that radius always stays the same length. We have some triangle width, and we have some triangle height that flips over. When we're talking about sine and cosine, when we're talking about trigonometry, we're talking about this relationship between triangles and circles. So let me throw this back over here, and let's go to our notes. Before we start exploring, let's get a couple of things defined. So for the unit circle, and the unit circle just means we have a radius of 1. It is 1 unit. There's two things we need to define. The cosine function describes the co-height or the width of a triangle at a given angle. The sine function describes the height of the triangle at a given angle. So get these definitions down, unpause your screen, and then go back to this. If we look here, this green line here, that is going to be our cosine. All right, and you'll notice that it shows up as cosine of some angle equals 0.81. Then we get the height of the triangle. Okay, that is going to be what our sine function looks like. All right, and you'll notice over at the top left, it gives us our sine function there. Another thing you'll notice is that because we have just a radius of 1, the sine function shows up as our y value on the unit circle, and the cosine function shows up as our x value on the unit circle. So let's go back here. And we're going to kind of define on our notes. I've zoomed in a little bit, but you'll want to define this on your notes, what exactly is happening in that GeoGebra tool. So if we start at our origin, and let's just make a line going out. Actually, let me undo that. Let's make this line hit our unit circle exactly on the edge here. Okay, and we have a radius of 1 with that line. If we trace down, sorry, I just wanted to make sure that my colors were correct here. If we trace down from that point on our circle, that gives us our height. This spot right here, this is our sine of theta. And theta is going to be however much we rotated from that kind of 3 o'clock position, from that x coordinate. Okay, the other thing that we can do with that triangle to complete it out is we can draw the width here. And that width here is going to be our cosine of theta. So if I go back to GeoGebra, wherever we're at on our unit circle, wherever we're at on our rotation, we have a triangle, and that triangle has a height of blue, that's our sine function, and a width of green, that's our cosine function. Okay, now as we move around our triangle, and I'm going to lose this graphic real quick, I'm sorry about that, the way I did my graph. As we move around, our cosine values and sine values are going to change whether they're positive or negative based on the quadrant we're in. This is how they go. And this is something we'll also want to get down in our notes. When we're in quadrant 1, which is this first quadrant here, this is 1, this is 2, this is 3, and this is 4. Our cosine values are positive, our sine values are positive. All right, and that makes sense because if we look here, we are right of our y-axis, we're above our x-axis, so we have positive values there. But watch what happens as I shift over into quadrant 2. My cosine value has become negative now. My sine value is now positive still because I'm above my y-axis, but I'm above my x-axis, but I'm left of my y-axis. So notice how in quadrant 2 our cosine values are negative, our sine values are positive. As I rotate into the third quadrant, so I dip below my x-axis for the first time, notice now how both my sine and my cosine are negative. And finally, as I go into my fourth quadrant, that last one, my cosine value is positive, but my sine value is negative. So those are just a couple of key things to highlight before we move on to this next activity. And what we want to do is we want to go ahead and build up a unit circle of values for key angles. So what you'll do is you'll go around and you'll say, all right, with my GeoGebra tool, I'm going to go to this angle 30. I'm going to pull my sine value, and I'm going to pull my cosine value. So if I go to that, go to my angle 30, and we can start to use the arrows to fine tune it, we'll see that my cosine value, or my x value here, is 0.87. That's the width of my triangle, and my height of my triangle, or my sine value, is 0.5. So let's just go ahead and write that in exactly as we see it on our unit circle. Let's make a little point here. We know that we have 0.87 as our cosine and 0.5 as our sine. And notice how as you go around, our cosine and sine are always going to line up with our x and our y. So let's try that one more together. Then I'm going to ask you to complete the whole thing by yourself. So if we go over to, let's say, 135, we'll get a height there, we'll get a width there, and at 135, if you look at your GeoGebra tool, 135, 135, 135, I'm going to have to use my arrows to fine tune it. We get a negative 0.71. That makes sense, a negative cosine, and a positive 0.71. So at this point here, we have negative 0.71 and positive 0.71. Now, you're going to have to go through and find cosine and sine at all key angles. So every spot on the back of your sheet, you are going to want to find. And so it looks like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 14, 15. All 15 spots you want to fill out here. Once you've done that, unpause your screen and kind of rejoin us to finish out these notes. So once we have our unit circle completed, we can actually use this to determine values of cosine and sine. And this is something that in Math 4 and Pre-Calc, you're probably going to have memorized, and you're probably going to have memorized as like different square root functions. But for now, we can just focus on the decimals. So if I'm focusing on trying to find the cosine of 60 in example 1, all I need to do is go to rotate up to 60 on my unit circle. And if I'm pulling that cosine value, I'm pulling that x value, that width value there. And so my cosine value there is 0.50. Cosine of 60 is 0.50. If I want to go to my sine of 120, then all I need to do is rotate over to 120, trace up, and my sine, I'm pulling my y value, right? That's 0.87. And lastly, let's hit sine of 240. I'll use purple for this last one. We're going to rotate all the way around to 240. And the sine value is my y value. It's the height of my triangle, and that is negative 0.87. Now, um, the unit circle shows some key values for all of our angles. But if we go back to GeoGebra real quick, we'll see that, hey, even though the angle, let's say 65, doesn't show up on my unit circle, it still definitely exists in real life. And so these cosine sine functions have values for every single angle. With the unit circle, though, we're just mainly concerned about those key angles. Um, However, Desmos and our calculators, they have sine and cosine functions programmed for everything. The one thing we need to make sure, though, is that the settings are correct when we do that. So if you're going to use Desmos, let me pull that one up for you, Desmos here. What you'll want to do is you'll want to make sure that in this settings tool, notice how it shows up as radians to start. We want to make sure that degrees is what's located there. Similarly, if you use your calculator, you're going to want to click the button DRG and then make sure that DEG is selected so that you're operating with the right thing. Now, once you have those set up, it's really easy to calculate our sine and cosine functions. For example, 4, let's check this out. In Desmos, I have degrees. So all I really need to do is then type in the thing I'm looking for, cosine of 240, and we'll see that, hey, that's negative 0.5. Sorry, cosine of 230 is negative 0.64. And we're rounding to 2 decimal places here, so equals negative 0.64. Then we can do the same for sine of 75. And that would be 0.97. And lastly, we can do that with cosine of negative 130. And that would give us negative 0.64. Now, again, I want to stress the importance. If you have this setting in the wrong thing, notice how if I click on this wrench and I change this to radians, notice how all of my sine and cosine values have changed. We want to make sure that for today's purposes, we're operating in degrees because that is how all of our angles are spec'd in our problems, 230 degrees, 75 degrees, negative 130 degrees.